students, welcome back. So let's review all the reactions which occur in your chapter Study of Compounds Ammonia. Okay, so let's begin. First we are going to see the preparation of ammonia. So from ammonium salts, the very first is from ammonium salts. So let's take one ammonium salt, that is your ammonium sulfate. Okay, how do we prepare ammonia from ammonium sulfate? Reaction will be NH4 2SO4 plus 2NaOH, that is your sodium hydroxide, on heating gives Na2SO4, your sodium sulfate, plus your H2O plus your NH3. Next, ammonium sulfate, when it reacts with calcium hydroxide, okay, what you will get? CaSO4 plus H2O plus your ammonia gas will be evolved. So can you see ammonia getting prepared from your ammonium salt? Using the reagents, different reagents. First we use sodium hydroxide, then calcium hydroxide. Let's see ammonium chloride, another salt. Now we will take the chloride salt of ammonia reacting with sodium hydroxide. What you will get? The salt will change, NaCl. Water will be formed as it is and ammonia will be formed as it is. Simple. Then in lab, commonly in laboratory, what we use ammonium chloride. We reacted with calcium hydroxide, which is easily available, and what we get? Calcium chloride also we get, water, and then ammonia gas is formed. What we are concerned with this, right? Next, ammonia, when this ammonia reacts with H2SO4, when we make it react with an acid, concentrated acid, we get ammonium sulfate. Okay, we get this salt, ammonium sulfate, which we are using here, right? So we can prepare salt, ammonium salt from it. Okay, let's move on. When ammonia react with your phosphorus pentoxide, P2O5, in presence of water, H2O, you get what? Ammonium phosphate. Okay, see the reaction. 6NH3 ammonia plus P2O5 plus 3H2O will give what? NH4 3PO4. Okay, then ammonia, 8 molecules of ammonia reacting with your calcium chloride, that is your fused calcium chloride, and what you are getting? Calcium chloride dot 8NH. So you as you can see, it is just getting, coming together in the form of a molecule. Calcium chloride dot 8NH3. Okay. Next method of preparation is from metal nitrides. So first we will form metal nitride. Let's take one metal and let's take nitrogen. Okay, Mg plus N2 will give me Mg3N2. Can you see that? Mg3N2. Magnesium nitride. This magnesium nitride, when it reacts with warm water, H2O, will give me magnesium hydroxide and this ammonia gas. Can you see this? Ammonia gas. So this is how you can prepare ammonia from your metal nitrides. Okay, next, calcium and nitrogen will give me what? Calcium nitride. This calcium nitride will react with H2O, your warm water, and give you calcium hydroxide and your ammonia gas. Okay, aluminium and nitrate, aluminium nitride, similarly it reacts with water to give aluminium hydroxide and ammonia gas. So this is how we prepared ammonia from metal nitride, wherein first metal and nitrogen reacts and then the metal nitride react with your water to form your ammonia. Clear? Okay. Let's move on to Haber's process, extremely important, star mark it. Okay, double underline it, Haber's process. So let's see what's there in this Haber's process. Temperature is important, 450 to 500 degrees Celsius, high temperature. Pressure maintained should be 200 to 900 atmospheres. If catalyst finely divides iron, then promoter MO, molybdenum. Okay, if catalyst finely divides iron, then promoter MO, remember that. Impurities is CO, CO2 and H2S. Okay, carbon monoxide, carbon dioxide and your hydrogen sulfide. These are the impurities. Preparation of ammonium salt. First we will prepare ammonium salt. Ammonia and hydrochloric acid will give me what? Ammonium chloride, NH4Cl. So next reaction with ammonia and your nitric acid will give you with salt. Of course, your nitric salt of ammonia, nitrate salts of ammonia. So ammonium nitrate, chloric acid, hydrochloric acid, chloride salt, nitric acid, nitrate salt. Okay. Then next is sulfuric acid, then sulfate salt. So we got ammonium salts from ammonia and the acid. So ammonia and acid will react to form the ammonium salts. Remember that. Okay. Ammonium hydroxide, ammonium hydroxide react with your hydrochloric acid to form NH4Cl plus H2O. So this time you are just extra what you are getting H2O. So when you are not using ammonia, instead of ammonia, you are using the acid as the same, okay, but not ammonia but ammonium hydroxide. So this is what you are getting. Ammonium hydroxide plus nitric acid, nitrate salt of ammonia, ammonium nitrate plus H2O. Then sulfuric acid, NH4OH plus H2SO4 will give NH42SO4 plus H2O. Right? Let's see combustion. Combustion of ammonia in presence of oxygen, of course. So ammonia plus oxygen, okay, will give you what? N2 gas, your nitrogen and your H2O. This is in the molecular form, it is getting converted to nitrogen. Okay, ammonia is giving you nitrogen gas. Catalytic oxidation of ammonia. So ammonia and oxygen in presence of PT, platinum, in presence of platinum at 800 degrees Celsius. See, it's important. You get what? NO, 4NO plus H2O plus a lot of heat. Okay, catalytic oxidation. So how do we remember? See, as it is catalytic, you will use a catalyst. As you use a catalyst, a particular temperature is required. Simple. Oxidation in presence of oxygen. What are you reacting? Ammonia. And these are the products that you are getting. Simple. Okay. Next is what? This NO will react with the oxygen and form NO2. We know this reaction. NO, this NO plus O2 will give me NO2. Okay. So let's talk about the basic nature of ammonia. So ammonia readily accepts protons. Okay, ammonia readily accepts proton to form NH4. From NH3 it becomes NH4 easily. So as you can see, it accepted proton and what it formed? NH4OH. This proves the basic nature of ammonia, right? So NH3, when your ammonia get dissolved in water, give you ammonium hydroxide. NH4OH is a weak electrolyte also we saw, a weak base also we saw, which dissociates to form again NH4 plus ions and OH minus. Okay, let's see the reaction with FeSO4 iron sulfate plus NH4OH, that will give you NH42SO4. Okay, NH42SO4, FeOH twice, we saw this reaction earlier also, dirty green precipitate which is insoluble. Clear? Okay, iron chloride, ammonia, ammonium hydroxide will react and form ammonium chloride salt and FeOH thrice as the precipitate, which is reddish brown colored precipitate. Simple. Copper sulfate, ammonium hydroxide will give you what? The base ammonium hydroxide will react with the copper sulfate to give you what? CuOH twice, the precipitate, pale blue colored precipitate, and your ammonium sulfate. This all proves the basic nature of your ammonia. Correct? From ammonia first we formed the base ammonium hydroxide and reacted with different salts to form different precipitates. Okay, next. Copper hydroxide plus your ammonium salt. Let's see the reaction, okay, important. CuOH twice plus NH42SO4 plus NH4OH excess. This reaction, we are continuing with this reaction. Okay. So NH4 twice SO4 plus NH4OH, the excess of ammonium hydroxide, and you will get water and you will get this complex of tetraamine copper sulfate. This complex. Color deep blue or inky blue. Basic nature of ammonia. Okay, copper hydroxide and then this 4NH4OH excess will give you hydroxide complex of this ammonia, tetraamine copper. Okay, what you will get this complex which is deep blue or inky blue sol, which is soluble in water. Okay, next is what? Zinc sulfate plus NH4OH. Okay, zinc sulfate, what you will get? NH4SO4, NH42SO4, ammonium sulfate and your zinc hydroxide. Okay, gelatinous white PPT. We saw this in reaction of acid base also. Correct? But here we are using it to prove the basic nature of your ammonia. Okay, then zinc hydroxide will react with ammonium sulfate and your NH4OH excess and it will form water plus your complex which is tetraamine zinc complex, zinc sulfate, colorless. Okay, so here as you can see the similarity of this with this particular part, similarity of this reaction with this reaction, correct, wherein you used your product, this product with excess of ammonium hydroxide and formed this complex, sulfate complex. Now we have to form hydroxide complex. So what you will do? NH4OH will use excess NH4OH, okay, and our product of zinc hydroxide, okay, zinc hydroxide plus NH4OH excess will give me H2O plus your tetraamine zinc hydroxide. This is another complex which is colorless, okay. So the copper and the zinc reactions prove the basic nature of ammonia. Okay, now let's talk about the reducing nature of ammonia. So from this reaction we will understand the reducing nature of ammonia. Now as you can see, ammonia can easily donate this hydrogen, which proves its reducing nature, right? It can easily donate this hydrogen. How? As you can see here, and itself it will get oxidized. So NH3 plus CuO, it will donate the hydrogen here to this O and it will become H2O. Your copper will be your pure copper here, and this itself will get oxidized by giving away the hydrogens and become the nitrogen gas. So this proves the reducing nature of ammonia by the donating the hydrogens. Okay, let's see another reaction. Ammonia plus your lead oxide will give you pure lead plus H2O, okay, plus your N2. Your ammonia getting oxidized to N2. Simple. Next, excess of ammonia we are taking, only ammonia, excess of ammonia, okay, and reacting it with chlorine. See what you are getting, NH4Cl, ammonium salt, and your N2. Again, it donated the electron, it donated the hydrogen and itself got oxidized to N2. Okay, it's a very strong reducing agent. It reduced this. Okay, it reduced your chlorine. Similarly, it reduced your lead in this. It reduced your copper in this. Okay, let's move on to the next one. Ammonia reacting with your chlorine. Okay, how many? 3 chlorine. But here we are not taking excess of ammonia. We are taking excess of chlorine here. Okay, and what it will form? This it will donate one hydrogen and it will form hydrochloric acid HCl. And what will be left? N and this 2Cl, 3 Cls from here, NCl3. So it forms what? Nitrogen trichloride. So I hope the reducing nature of ammonia is also clear, where it can easily donate its hydrogen atom and reduce the other compound with it, the other reactant which is there. Okay, so with this we complete all the reactions of your compound ammonia, all the important reactions. Go through the reactions. Best of luck. Thank you.